And there is more. That's water. Water. That's the question. Balance is balance. Using redox. C2H6O, sulfuric acid, sodium dichromate, another organic C2H4O, chromium 3 sulfate, sodium sulfate, water. Okay, let's balance this funness, okay? Now I actually saw this two different ways, but I want to do a particular way with you, and I want to make sure I pick the one that did it the way I want to do it with you. You know what I mean? Okay, I think it's this one. Yes, this is the... There's more than one way to solve this, actually. Okay, first, I'm going to do a certain color. This is nothing new here. This is true in all circumstances. Cut. This is my style again. Your instructor may have a different style, but my recommendation, if you see any of these ions or water in solution, when it's a redox, just ignore it. The reason, and there's one right there, water. I'm going to ignore that, water right there. The reason is, water is added in the half reaction method. In step 2, when you're balancing the oxygens, you add water. So it kind of messes me up when I start with water, or H plus or OH minus. Okay, so I'm going to ignore any water, H plus or OH minus. I always do this. This is my style of solving, if you have it. Okay. So that's step 1. The second thing is, I'm noticing this has a lot of action. It obviously has some spectator ions. For example, one of the spectator ions is sodium. So it has a lot of spectator ions here. So what I'm going to do is locate the spectator ions. How do I do that? I'm going to find the strong electrolytes. This is, remember when you're doing net ionic equations, you have to identify the strong electrolytes and then separate out the in solution and then cancel the spectators. That's what I'm going to do here. Again, this is my style. Other people might solve it differently. So some strong electrolytes that I'm finding here, 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 and here. There's a lot of them. How did I know that was a strong electrolyte? Was that a question? Yes. Yeah, if it's an aqueous ionic or a strong acid. So, ionic, ionic, that's ionic. What's ionic? How do you know it's ionic? You're looking for a metal and non-metals. So this has metals, that has a metal, that has a metal. So they're ionic. So I'm underlining them as strong electrolytes. This one, I'm going through this slow just to make sure you got it. So this is going to take a little while. Okay, this one, how did I know that was this is a strong electrolyte? Strong acid. How do you know, oh, I'm going to ask the other class, not my class. How do you know what's a strong acid? There we go, nice. Which class are you in? Oh, nice. I figured he did that. Good for him. Good for him. This is, I mean, well, I'm agreeing with people who teach it the way I teach it, I guess. If it's on this chart, it's strong. This is my chart. Your book has a chart that looks really similar. Topodokus probably has one that looks really similar. If it's here, it's strong. What if it's not here? It's not strong. In Chem 2B, you'll learn why. But in Chem 2A, it's a little early, but we do need to know what an acid and base is in Chem 2A, so that's why you learn it here. But you'll learn why that's true in Chem 2B. It has to do with size and electronegativity and stuff like that. Okay. So next, I'm going to write those out separately. Oh, I'll zoom out. I'm going to write the ion. By definition, a strong electrolyte separates out in solution. So I'm going to write the ions out all separately. There's three of those. There's 2 and a plus, and there's a sulfur. Okay, so you'll notice I'm writing all the ions out separately. I'll zoom in a little bit, but I can't quite zoom in landscape mode here. Okay, see how I wrote all the ions separately just for the strong electrolytes? Okay, so that I did in purple just now. Now, I'm going to see what's the same on both sides. Here's my style. I'm going to tell you the both styles. First, not my style. You can leave those in there and balance it with those. You just need to figure out which side it goes on oxidation reduction, which is not always an easy task. Both of these styles have a level of difficulty. The other style is what I'm going to do. I'm going to get rid of them and then add them back when I get to my answers. Okay? They both have good and bad parts about them. Okay? So just so you know, another way that I will not do is to keep them in the whole way through. I'm going to put them back in every time I get to a reporting answer. All right, so what I'm going to do is cancel them. So the chromium doesn't cancel, for example, but the sodium does. I can dump a sodium on it, 2 sodiums on each side. Now I got to remember to add the sodium back later. Sulfate, gone on both sides. Now, notice there's not an equal number of sulfates. That happens because it's not balanced. But, so I'm going to cancel the sulfates. They will be balanced at the end of the problem if I do stuff right. They're not balanced now because the problem's not balanced. I cannot count the chromium because the chromium is in 2 different species. So it's different, 3 plus versus Cr2O7, 2 minus. I think that's all I can cut right now. Okay, now I'm going to write down what I have left over. So let's do that. What's left over? 2H6O plus. Oh, do you see this 2H plus right there? What am I going to do with that? I'm going to ignore it because what's written in brown. H plus, I will not write it. That H plus right there. Because I cut all waters, OH, and H pluses. Does that kind of make sense? It will come back to us, don't worry. Okay, so I won't write the H plus for that reason. The next thing left is Cr2O7, 2 minus, goes to C2H4O plus 2Cr3 plus. That's it. I think that's it. Everything else canceled or got cut. Yes? I have to balance it now because it's redox, and you might be thinking of balancing by inspection. I think that's going to be near impossible to balance just looking at it. Yeah. And the question on the exam, if you've seen my redox questions, or most instructors really do this, we tell you, the first part is what's oxidized, what's reduced, and then what's the reduction half reaction, then what's the oxidation half reaction. So we walk you through it. You know it's a redox. There's no surprise. Okay. And you'll see that on the practice finals, actually. Okay, so we've got oxidation, reduction, half reaction. Let's get on that business. One side is this, and then the other one is the one, so one has the carbons and the other one has the chromiums. I'm keeping this 2 with the chromium, but I don't have to. You don't have to keep the 2. I kept it. Okay, so there's both half reactions. Look at the chromium. Is that oxidized or reduced? It goes, what's the charge oxidation state of this chromium right there? Plus, not plus 7, 6 plus 6, I think. I think it's 6. Yeah. So is this oxidized or reduced? Yeah. If the oxidation state goes down or is reduced, then it's reduced. If the oxidation state goes up, then it's called oxidized. So this is reduced. Because it goes from 6 to 3. This is oxidized. All right. Now let's balance using the half reaction method. There's the 4 steps, or in my class there's 4 steps. Step 1, let's do the top one. It'll be more exciting probably. Top one, balance whatever is not oxygen or hydrogen. That's carbon, and there's already 2 carbons on each side. Step 2, balance the oxygens with water. There's already 1 oxygen on each side, so we're good. Step 3, balance the hydrogens with H+. Okay? I've got 6 here and 4 there. So plus 2H+. Step 4, balance the charge. What with electrons? Will I put the electrons on the right or the left? How many? Just 2, because plus 2 minus 2 gives a 0 overall charge on both sides. Okay, let's do the reduction half reaction. This one will be a different kind of field. Step 1, balance whatever is not oxygen or hydrogen, that's chromium. There's already 2 on each side, so that's where that 2 comes from in front of the Cr2+. Step 2, balance the oxygens with water. There's 7 on the left, I need 7 waters on the right. I want to point out something, by the way. See that water right here? It came back. If you guessed that the water was here, you'd be wrong. That's why I ignore it, because I don't want to guess the wrong one. Okay. Step 3, balance the hydrogens with H+. There's 14 hydrogens on the right, so I need 14 hydrogens on the left. Step 4, I need to balance the charge with electrons. Will I put the electrons on the right or the left? The left. Now, tell me how many. Plus something. Oops. Okay, I'll tell you 6. Okay. 14 minus 2 is 12. 14 minus 2 is 12. And over here is 6, 2 times 3. So 12 minus 6 is 3. That's how I got it. So make sure you can do that. Sorry, I'm speeding you up. I want to end at a reasonable time so I can go home and watch TV. Okay, so, okay, these are the half reactions. Now, let's take a pause for a moment. We're going to have to do a little bit of work. If I'm reporting an answer, which I would be on a final, they will ask you for the oxidation half reaction and the reduction half reaction. I need to put the spectator ions back now. Okay? So now I need to figure out where they go. Now look back at the top of the screen here. I'll squeeze down a little bit. Okay. This, okay, let me write out what they are. They are the spectators were sodium, and they were sulfate. Oh, and that's it. Okay. Shorter list than I expected. Okay. The sulfate went with the chromium, so I better put that down here somewhere. Is that okay? And the sodium, right here, went with the chromium. So they're both going down here. Okay, no spectator ion will go up here in the oxidation half reaction. This is the final answer for that one. So both will go down here. So I'm going to add back some sodiums and some sulfates on this side. Where am I going to add them? The same place I removed them. So I'm going to add some sulfates with the chromium right here. I'm going to put it right back where it was born. And then I'm going to put these sodiums right there. And I'm going to need to balance this out with some H2SO4. Okay, so you're going to see how this works. So this is probably, I mean, I didn't do one like this in class, and if your instructor didn't, this would probably be the hard step of the problem. Okay, so again, some other instructors might keep these spectator ions all the way through. Okay, so I'm going to change that to Cr2SO4. Do you see how the 2 stays there? No loss right there. So I'm adding really 3 sulfates here. Okay? What else am I going to do? This one, right there, I'm going to put some sodiums in there. To balance, because each sodium is +1, I got to add Na2Cr2O7. All right, so I just added 2 sodiums. Oh, notice, so there's 2 more molecules I have to add. I'm going to point to them with my pens. The sodium sulfate has to come back, because there's sodium's here, so it has to be over here. And the sulfuric acid, sodium sulfate and the sulfuric acid have to come back. Remember, I canceled those earlier. So these have to come back. Anything you cancel has to come back when you're reporting your answer. Again, you could have kept these all the way through and they would still be here, but then you'd have the difficulty of balancing this with spectator ions. I'm preferring to balance this first and then put my spectator ions before I report the answer. Okay. So over on this side, I'm going to have to add back a sodium sulfate because it was right here. And over on this side, I'm going to have to add a sulfuric acid because it was right here. Okay, let's see how that's going to work. Let me rewrite the answer here a little bit. So I'm going to have a Na2CR2O7. On the other side, I'm going to have a Cr2SO4 and I'll have 7 waters. Okay. Now I'm going to have to add the sodium sulfate back. So plus Na2SO4. Okay, now the question is, how many of these things am I going to add back? Well, there's one there. Oops, let me zoom out a little bit. There's one there. So let me just start with 1 and see what happens. So I'm going to add 1 back because I had 1. Okay? All right, how many sulfates do I have on the right-hand side now? 4. 3 here, 3, and 1. So I'm going to add how many sulfuric acids over here? 4. Like that. Okay, so now my sulfates are balanced. Are my sodiums balanced? Yeah, 2 on each side. So those spectators are balanced. What have I not included that I still need to include on this? 6 electrons, sorry. These. And? Got the water right there. Somebody mentioned water. There's one thing I'm missing. The H plus. How many are left? I used some right here. I used some right there where my finger is. Yeah, I used 8 here of 14, so 6 are left. Because I had to use 8 to put the sulfate back in. And there's 6 net left with no sulfate. This is my reduction half reaction. So, I don't know, you might be happy if you like this stuff, but for the rest of you, I apologize. Yeah. Okay, 2 things. One is I'm not done with the question yet, but 2, is it for acidic or basic conditions? Let me see how Topadakis had this one. It actually doesn't have to be stated. It would be stated on the test though. This is for acidic conditions. Does anybody know why I would not have to say that? You have sulfuric acid. Has to be acidic conditions if you have an acid. So this is for acidic conditions. On the test it would say that explicitly, but technically I wouldn't need to say that. Okay, now let's finish the problem. I have 2 half reactions. This one and this one. Those are my 2 half reactions. I'm going to multiply the top by 3 to get 6 electrons and the bottom by 1 to remain at 6 electrons. Okay, so I'm going to scoot this up and do my final answer here in landscape. Okay, let me write everything. Hopefully I don't miss anything. I've got 3 C2H6O. I'm going to write all the reactants first. Plus Na2Cr2O7, sodium dichromate. Plus 6H plus 4 H2SO4. I don't need to write the electrons, they cancel. Then all the products now. 3 C2H4O plus 6H plus chromium 3 sulfate, Cr2SO43, plus sodium sulfate, plus 7H2O. I think I got everything, and if I did not miss anything, you are looking at the final answer. Oh yeah. Oh wait, there's one thing. I don't know what you said, but I hope you said to cancel the hydrogens. There's 6 on each side. Oh, state symbols. I believe we're not going to ask you for state symbols. Oh, okay, you're welcome. Oh wow. Yes, no state symbols. Yeah.